Welcome engineers. In this video we will talk on how to configure hardware and establish communication between your PC and Siemens PLC using Cymatic Step 7. Also, we'll discuss about what system faults and bus faults are, how they occur, and how to prevent them. Let's dive right in. Before we begin the configuration process, let's quickly recap. Cymatic Step 7. This is the software used for programming and configuring Siemens PLC systems. S7300 PLC. This is a modular PLC system, widely used in industrial automation. Now, let's get started with configuring the hardware. Open Cymatic Manager. Go to the File menu and select New Project. Here I am change file directory or file location. Next, give your project a name and click Create. In the toolbar, click on Insert. Go to the Station folder and select your PLC model. For this tutorial, we'll choose the S7-300 PLC. You'll now be presented with the hardware configuration window. This is where we will define our hardware. At the right side here are the catalog folder. From the available modules, select your CPU. In my case I have CPU 313C2DP. Where 313 is CPU model, C indicate the CPU is compact type or modular type, and 2DP indicate number of port and type of port are available. A DIDO module are attached with this CPU. And add extra DIDO and AIAO modules. And a CP module are add but we ignore in this video. Now jump to the hardware section. Click on Cymatic 300. Click on Rack 300 and double-click on Rail. Now see how to arrange the modules in the rack. If there have physical PS module, only then, add at the software. If there haven't physical PS module then leave the rail one. Next, rail number to add CPU. Again, if there have physical CP module, only then configure at software, otherwise leave the rail number 3. Next rail number 4 and 5 for the SM modules. And finally, if there have IM and FM module then add to the software. IM module are used for RIO station or remote operation. Now, drag and drop the CPU into the rack area. But before add, we need to check the serial number or chipset number of the CPU. In 313C2DP we need to select correct serial numbers CPU. To check the serial number look at the bottom of the CPU. Again in 313-6BF03QAB0 serial number there have to version, in my case it's version 2.6. To check the version, try to find beside of ports. Double click on it. Click OK. In compact type PLC, DIDO input address and output address are start from 124 by default. To change it, double-click on Address. Go to the Address section and untick System Default for both. If you want to change, and write as you want. At rail number 3, we haven't CP module. So, leave it blank. Also note, in 300 CPU model, rail number 3 is fixed for CP module. Other module are not placed at rail 3. If you configure other module at rail 3 in software, then system fault occur. In 400 series CPU you can place other module at rail 3. At rail 4 and 5 you can add other modules, like I/O modules, communication processors, etc. For example, add an DI16, DO16 digital input-output card. For SAM modules, click on SAM300, go to DIDO300, and again check serial number. We have SAM3 to 3 DI16, DO16, 24V DC, 0.5 ampere module, and here the chipset number. Dragging them into the appropriate slots on the rack. For serial number look at the bottom of the modules. Now, add AIAO card at rail number 5. Here, we have AI4, AO2, 8-bit card with 334-0CE01-0AA0 serial number. And last, click on Save. Next, click on Save and Compile. Here, I face a software problem, just ignore this. Now, we need to establish communication between the PC and PLC. In the option menu, go to Set PG-PC Interface. Wait to open. Now, select the correct communication driver. For example, if you are using Ethernet to connect to the PLC, choose Ethernet driver. In my case, I am communicate with MPI adapter, so I am choose for PC adapter MPI1. Here, it's not show, because while I am recording the video the adapter not connected with PC. After, select your communication driver, click on OK. For configuration, I am turn on simulator to show the downloading process. For simulator, click on Run P to turn on the CPU and change to PLC Sim MPI. After save and compile the hardware, click on the download button. Click on OK. And click on View. When the physical PLC are connect, it's show the CPU model, then click on Update and click on OK. I am turn on the simulator to describe the CPU LED. While CPU turns off, it's indicate by stop LED. The stop LED glow in red color. While turn on first SF LED turn on, which is indicate system fault. If SF LED turn on constantly, mean system fault occur. And when BF LED glow, mean bus fault occur. Here this purple color cable, which is a Profibus cable, may be fault. A system fault occurs when there is an issue in the PLC's hardware or communication system. This could be caused by incorrect configurations, faulty hardware, or communication failures. Common cause of system faults: incorrect wiring, incorrect CPU settings, and many more. How to prevent system faults during communication? Take a screenshot for future help. A bus fault occurs when there is a problem in the communication network or bus system, example MPI, Profibus, or Ethernet, that causes the CPU to lose connection to its devices. There are some points of how bus faults occur in CPU. Overload communication bus, cable damage, mismatched baud rates, and faulty modules. How to prevent bus faults? Take a screenshot for future help. If you found this video helpful, don't forget to like and subscribe. If you have any questions, leave them in the comments below. Thank you.